Go in here. Okay, so today I'm going to do some friction sample questions from the book. These ones are worded a little bit differently, but that's a good experience. Gives you something sort of little different wording. You have the sheet in front of you. Eventually I'll give you some textbook questions to work on, so if you don't have a textbook, you might want to get that in the near future. Alright, so let's begin. Johnny, you ready to go?
Yeah, I'm watching.
So we got example number 8 here. These are textbook questions with friction. Lawnmower of mass 12 kilograms is being pushed by a force of 150 newtons horizontally and 40 newtons down. If the kinetic coefficient of friction between the wheels and grass is 0.9, which is like crazy high, find the force of friction acting on the lawnmower. Let's draw a picture. How much room do you guys have? Not a ton. Don't draw a big super picture. Like Riley did. Okay, so we are pushing this lawnmower. It says 150 newtons horizontally and 40 newtons down. So that means that this is 150 and that's 40. And you might remember yesterday I was talking about there's pulling up on objects at an angle and then there's pushing. So this is an example of a pushing, isn't it?
Yes.
If the kinetic coefficient of friction between the wheels is 0.9, find the force of friction acting on the motor. So we're pushing that way. I guess technically it should be like this, I guess, right? I know. I tend to do it like that, like a lawnmower, right? It's okay. We'll put the friction like this, right? It's okay. Just do what you need to.
Friction would be going.
Friction would be opposite, right? Now, Danielle, is there a weight force here?
Yeah.
And is there also a normal force?
Yeah.
And are they balanced?
No,
Yes.
They're not, because there's one more y, right? The FAY, which is the 40, really, right?
Yeah.
Okay, so we need to find FF. Now, you'll notice it doesn't say anything about acceleration or it doesn't say anything about a constant speed, does it?
No.
Now, I don't know about you. Who has cut the grass before? Almost everyone.
Right.
Do you start at one side and accelerate as you go across the lawn?
Yeah,
No.
You just kind of walk at a constant speed. Still walk at a constant
I
speed.
sprint.
Okay. So let's just see what happens here. Well, let's find the weight force. Mass times gravity.
I got a riding lawnmower because it takes like 2.5 hours to finish my lawn.
So that's going to be 12 kilograms. Why is the friction what? 12 times 9.8. 117.6. Now, is that equal to the normal force?
Nope.
No. But you can say that the y, the F net y, you can say that the F net y is in fact 0, right? How come? It's not accelerating up and down. And that F net y is made up of the weight force plus the normal force plus we'll call it the FAY, the y component of the applied force.
Oh, yeah.
Right? Remember doing this yesterday?
Kinda.
So the weight force, now that 117.6 is actually, I'm surprised no one yelled at me, actually negative.
Hey, the 117.6
Right?
is negative.
You're right, Johnny. We're going to solve for Fn, and the FAY is 40, but that 40 is
No.
down.
Get up, get down.
Right?
Yeah.
Everybody get down tonight. Exactly. Right. Is that what you were thinking?
I was singing down with the sickness.
Oh. So the Fn is going to be 117.6 plus 40, which is 157.6. In fact, we have increased the normal force, right?
Yes.
Right? If I'm pushing down on the table, it's going to be a whole lot harder to slide, isn't it? Because I've increased the friction. Right?
But you're not even pushing like if you.
What?
I'm pushing down with 40 and sideways at 150
Okay.
at the same time, right? They've broken it down into components already for you. Now, you should be able to go mu equals FF over Fn. So 0.9 is equal to FF over that 157.6. So we take that number there, that 157.6, multiplied by 0.9, which is huge friction, 141.8. Right? And that's all it really asks for. It says find the force of friction acting.
And it would be negative.
It would be negative in that it's to the yeah. I suppose. I wouldn't worry about whether it's positive or negative.
If we didn't have that picture showing that friction is like in the positive direction, and we put that it was positive, would that be?
Oh, you know what? I probably wouldn't even catch that. But you're probably, that it would be wrong, yeah. But I don't know if I would actually catch that. She's saying that if you didn't have the picture and you had positive here, would you be wrong? Like,
He would be like, I'm gonna give it to you.
No
because it's
mercy.
not-
yeah, I wouldn't get that.
For me, just be like, that's wrong.
I think example number 9 is a follow-up question, it's not?
Yep.
Find the acceleration of the lawnmower. Now, did I not just finish saying that when we push lawnmowers, they tend to have an acceleration of 0?
Yeah, I did.
So is this lawnmower actually
So
accelerating?
at that point, it's just common sense.
Well, you might think it's 0, but remember, I'm just going to redraw it.
Well, sometimes it's
It's- Not 140, it's actually 40 down and how much sideways? One what?
What's the degree?
150.
That's common sense.
Someone said what's the degrees? But what was the friction force?
141.
141.8. Oh. So if there's an applied force of 150 sideways, and friction is 141.8 the other way, there is a net force, isn't there?
Yeah.
There is an F net, can I call it F net X?
Sure, why?
Like the X, the left and right total. So that's going to be 150 minus 141.9. Is that what that is? Or no, it's an 8. So that's going to be 9. That's going to be 8.2. There's actually a net force of 8.2 sideways. And so now you can go F net is equal to MA. Was it 12?
So if you had a question where there was an F, like a F net Y and an F net X, would what happen?
No, but I mean, just to keep it separate here, we should probably put that. Basically, all the F nets you've dealt with up to now have all been F net X, right? But it's not said anything with that. Okay, so that's not particularly hard, really, is it? No, I don't think so. Okay. You guys could probably do this one on your own. Let me just see what's coming up here. I forgot, it's been a while. Oh, yeah. So you want me to do this one?
Yeah.
Okay. 2 people pushing horizontally on a crate of mass 50. One person is pushing with the right, or from the right with a force of 50. The other is pushing from the left with a force of 80. Kinetic co-friction is 0.3. Find the acceleration to crate. This is the same question, Rose, for all intents and purposes. One is from the right, so that means to the left. From the right, so that means to the left. So that means 50 that way. And the other is pushing from the left, so to the right, with 80, right?
One of them would just be a little friction.
So there is actually friction, isn't there? Which way would the friction be?
There'd be
To the left. There would be friction to the left, right? Because there's obviously motion to the right.
Yes. Yes.
Right? You liked it better when there was 3 arrows. 5 arrows aren't better than 3? What should I do first? Find the what?
Find net force.
Well, before that, though, Todd. I think I got to find FW, don't I?
W.
W. 50 times 9.8 minus, I guess. So that's going to be minus 490. I got that number memorized.
Why do you have that?
Because you know how many times I've taken 50 times 9.8?
Quite a few times.
And plus I know that 50 times 9.8 is like almost the same as 50 times 100. Or sorry, 50 times 10. 50 times 10 is 500. So 0.8, right, is 0.2 away from a whole. 0.2 is a fifth. So a fifth of 50 is 10.
I think you just remembered.
4.9. And they say that whole, You ever see that? Sorry, my little rant there for today. Okay, so I got 490. Now, is the weight force 490?
Yes,
Why is the weight force 490, Megan?
because we did the equation to get the weight force.
Yeah, but why is it? Why in this case is the FW equal to the
There's
FN?
no,
There's no vertical. Bingo, Rod.
You asked me what the FW was.
Did I say that? Oh.
there's no spheres. What?
Mu equals FF over FN. Mu is 0.3. Then 490 times 0.3. 490 times 0.1 is 49. 3 times 49 is 147.
Holy
That's
crap.
fast.
That's impressive.
I understand how math works.
What?
Well, I mean, you wrote it.
That was really cool.
Plus that dumbest question.
I'm on the.
Dear God.
That's really
Thanks.
Oh, God, can I-
Okay, so now what do I do here? Now my FNet X, is, now are you okay if I say F1 plus F2 plus FF? Are you okay with that?
Wait, why do we need this?
F81? Okay,
Can I just put the difference of them and call them FA?
sure. You can call them FA and FB. Danielle wants me to call them FA1 and FA2. I like that. So that's going to be 80 to the right, positive,
Wait, why do we need to do this though?
because I got to find the net force sideways. Well, it doesn't really matter.
All this whole equation, okay.
80 plus or minus 50.
I thought we only did this if there was vertical force though.
No. Well, we need to find the acceleration of the crate. So the acceleration of the crate is based on the F net X, right?
Just put FA1 minus FA2.
Well, I like to show you're adding the forces, right? You're combining the forces. Adding a negative, Danielle, is more correct.
Oh, never mind, I understand.
So now here's the problem. 80 minus 50 is 30. Minus 147 is going to be minus 117 newtons.
That means it's going in the direction. That means it's moving left.
That means it's moving left.
It's going this way.
Hold on here. Let me get this straight.
But the picture,
Okay, Johnny? Push, come over here. Johnny's going to be the 50.
If it's going that way, what's the friction?
He's going to push the 50, I'm going to push the 80. Go ahead, come push. Right? So push, I'm going to push harder than him, right? So you're telling me if I'm pushing harder than him, it's still going to be because of friction, it's going to go this way?
No.
That doesn't make sense.
no, friction's more resistance to
What's
the
that?
force.
Going 80 this way.
There's friction on
Okay, Johnny, I'll go change up.
It's not going
I'll push with 80, he pushes with 50, but then it goes,
No.
right?
There's friction
What
on
do you mean
John.
friction on both sides?
Friction opposes the motion. Now, if there was no friction, which way would it go?
So when you're pushing.
It'd go with 30 newtons to the right, right?
Yeah.
But now there is, but there's more friction than there is, there's more friction than there actually is applied force.
So would it move?
So it's not gonna move, right? Like if I push just lightly on the desk, it doesn't like throw me that way, does it? Like, friction doesn't, friction's like a teenager, only does as much as it's supposed to, as it needs to. Did I say that on the record? I did. Right? If there's a net force of 30, 80 plus minus 50, how hard is actually friction pushing?
It's only pushing.
Only 30, right? This 147 is actually the maximum, but it only pushes as hard as it needs to. If I push with 30 and the friction force is 147, it's 0, right? It only pushes as hard as it needs to.
Well, like you need to.
Right? The friction doesn't go all in. It only, if I push with 30, Danielle,
I can handle it.
Why is it negative?
So the other guy was
it's to the left, right? But really, this is not true.
How
The,
can it be to the left?
it's not. The F net X is actually 0. That's what I'm getting at.
But then why?
What is asking?
Just down,
Could you
there's a
explain
bouncy
the
garden
whole thing?
below, okay?
Dumb.
I'll try, one second.
So hold there,
Okay.
even though he has more strength.
Let's say the friction force on my
Stop.
hole punch
I lose
is 20 newtons.
Oh, you're okay.
Okay. Friction force on the hole punch, Riley, is 20 newtons.
Okay,
Okay. I push with 5 newtons. What's the net force? 5, what did I say, 20?
Yeah.
5 and
negative 50.
20. So is the net force minus 15?
No.
No, why not?
More than 20.
If I push with 12, it's still not enough. I have to push with at least 20 to get it to actually move, right? So anything less than 20, friction just goes, I don't need all my 20. I just need as much as Ben is pushing. If Ben pushes with 5, friction pushes with 5. If Ben pushes with 12, friction pushes with 12. If Ben pushes with 25, friction pushes with 20, and the net is 5.
5. Oh my god.
Okay? So it's not going to work out mathematically.
If I push really hard,
Right.
it'll.
Now, Jared, we're good?
So you're telling
What if you're like pushing?
So, exactly. So here, my F net is 0, therefore my acceleration is also 0. It's not moving because
Because he's not
it's
pushing.
not pushing hard enough.
Oh my goodness. Oh,
Not pushing, it's not moving because he's not pushing hard enough. In fact,
So even though that guy's pushing.
no, I'm teaching here. It's not about the answer, Taryn. It's about learning something. Right? If this 50 wasn't there, would the 80 be pushing hard enough?
Yes.
Yeah.
Yeah,
No,
No,
it
the
couldn't.
maximum friction force is 147. The 50 is doing nothing.
It can't
The 80 still isn't enough,
can't even do the box.
right?
That is pretty in the box.
In order for it to be moving, the total applied force has to be more than the possible friction, right?
Maybe if the 30 and the 50 were pushing together.
If they were pushing together, then you'd have 130, and you still wouldn't have enough. Right.
Are any of your stupid jokes in here?
No, they didn't let me put any stupid jokes in there.
Darn it.
Very disappointing.
I was hoping for like a
You
name,
know, I was like looking for
like Milton in your mouth when he's going.
Oh.
Like,
No, I used people that I know.
Me.
Yeah, I think
Friday sheet.
this one here is a challenge.
Nope.
We have a 0.5 kilogram block being slid up a chalkboard with an applied force of 6 newtons upward, and chalkboard, and 2 newtons inward toward the board. If the coefficient of friction is 0.4, calculate the acceleration of the block. So, this is a weird one because it's not your traditional book on a table kind of thing. It's something being,
Pushed upwards with the gravity.
like this, right?
Like a pen.
Or whatever, yeah. Like the sticky pen thing. Okay, so 0.5. The applied force upward is 6. Let's label that one FA1 is 6. And F2 inward toward the board, so pushing on it, right? F2 is 2. And there is friction. Now, which way is the friction?
Going that way.
Down. How come?
Because you're pushing it up.
Yeah, that's the way it's going. Is there a weight force here?
Yeah.
Yeah.
Which way is it?
Down.
Also down. Is there a normal force?
Yes. There is a normal force. It's going up.
If it's just something dropping, there's a weight force, but there's no normal force. But is there a normal force here?
Yes. Or is it pushing out
Which
now?
way is it, Riley? Riley says it's this way. You agree with Riley? You and Riley are correct. Riley's pretty pleased with himself. He's correct. Okay, here is the question. How much is the normal force?
oh my goodness.
It's the same amount you're pushing against.
Is it the 2? You think it's 2?
Yeah. And
Would it be different because it's like,
Bourbon's nodding, it's 2. should it be
It's two.
2? Would it be -2
Yeah, I guess.
because it's left?
Yeah.
No.
Yes.
No.
It has to be.
It's just the negative just means to the left. I could write 2 to the left if I wanted.
Make sure like.
It's two.
Inverting, so when you get up here, it actually makes
And we should have taught you all the big words as well in kindergarten.
Yes.
You started off hard.
Yeah, like everything else.
It's harder. It's not negative. It's not negative. It's down.
All right, so we are to find the acceleration of the block. So to find we all know that the block's going up, right?
Yes.
So we need to find F net y. We need to find F net y, don't we?
Yes.
Yeah. Yeah.
Right?
And
So
you
the y forces are 6 up, friction force down, weight force down. Are the Fn and the FA2 balanced?
Yes.
They are, right? And so that's going to give me my FF actually. Right? So in fact, Fn is 2, or if you prefer, -2. Right? So mu equals FF over Fn. The mu value is 0.4. I'm solving for friction force. And the Fn, not the FW here, it's actually that -2. And so my FF is going to be 0.8. Now, is it negative because of this?
Yes.
Yeah, it is.
It's going down.
It's negative because it's down. Okay? But only because it's down. It doesn't come out of this. I'm manually changing it to negative because it's down. So the FF is minus 0.8. Is there a weight force? You betcha. 0.5. Now is this minus 9.8 down? Yeah. That's going to be minus 4.9. Right? Okay, so what is my F net y? Because that's what I got to find out, right? My F net y is made up of FA1. My F net y is made up of FA1 plus my friction force plus my weight force. Right, so that's going to be 6 up, positive. Friction force is going to be minus 0.8 because it's down. And the weight force is going to be minus 4.9. Now, is this person pushing hard enough to make it go up?
Yeah.
Yeah.
Looks like it, right? So it's going to be 6 minus what? 5.7, which is 0.3 up to 6 plus 2.
What's wrong?
Oh no, it's just 0.3, isn't it? 0.3 is my F net y. So this is a slightly different kind of question.
I like these ones. I think they're easier than the other.
Yeah, F net y then is equal to mass acceleration. 0.3. What was the mass of this block? Oh, 0.5. So my acceleration is 0.3 divided by 0.5, which is the same as times by 2. 0.6 meters per second squared up.
Wait, what?
Divide both sides by 0.5. Divide by 0.5, right? Not multiply.
They're funny.
Yep. The mass is 0.5.
I gotta write down some of these formulas.
A puck of mass 0.3 kilograms is sliding along an essentially frictionless patch of ice at 6 meters per second. Let me just draw the picture for you. Okay, so here's the puck sliding along the frictionless surface, and its initial velocity is 6, and I guess its constant velocity is 6. It encounters a rough patch of ice. We all encounter a rough patch in our life once in a while. With a coefficient of kinetic friction of 0.1, how long will it take for the puck to stop? So you're solving for t. I guess it's over here. Is that a what? 0.1, yeah. You're solving for T and you're solving for D. Now, over here in the rough patch, what are the forces that are acting? Is there a friction force?
It says
It encounters a rough patch of ice with a coefficient of kinetic friction.
it's
So,
good until it gets
it has an FF like this, and a normal force, and a weight force. So the F net X is actually just the friction, is it not? The F net X is actually just the friction. The F net Y is in fact 0, isn't it? Okay? So to find F net X, you got to find FF. Mu equals FF over Fn. Okay, give it a whirl.
No, I missed that.
So I got an answer 18.4. Did you get that? Is that what's in the book? Did anyone look it up?
no.
These are all on page 172, I think.
Net equals. We have to find out.
We did it to learn, Christine.
Wait, so this would be 0, right? Like the acceleration would be 0.
No, the acceleration is minus 0.98.
I mean, wait, how did we find that?
Right here.
Yeah, because the FA would be 0, right?
Okay, so now, I know there's not a lot of time left here.
We have to use them.
I have some questions oh, you're there.
And the other one, there was a.
I'm lost.
Now don't freak out on me.
I'm lost, Mr. Beck.
Yeah? Do you want me to go through this? Okay, let me just do this first, Danielle. You can watch the end of the video if you want. Here's some textbook questions to have some fun with. They're on page 188. Don't freak out. Numbers 39 to, it's only 48, so that's only 9 questions. Now, I'm not saying you have to do them all, I'm just saying you should be familiar with those kind of questions. Okay? How about I spend a second just going through this here?
Yeah.
Okay, so I found the weight force. 0.3 times 9.8 is 2.94. That's my Fn. I'll go down it right away. 39 to 48. Okay? My Fn goes into mu equals FF over Fn. That gives me my FF of minus 0.294. And the FF is the F net X because there is no other X force. Right? So F net equals ma. Plug that in. You got 0.3 for your mass. Your acceleration is minus 0.98. So in other words, it's slowing down at minus 0.98 meters per second squared when it encounters that rough patch.
Can I just call it the FNet?
Yeah. You're asked to find how long it takes. So I'm going to go VF equals 0 because it's stopping. My VI was my 6. It was going 6 when it encountered the rough patch. You're going to solve for T by taking the 6 to the other side and dividing by minus 0.98. And then you're going to plug that all into this one here and you get, I think, 18.4.
Okay, I guess
Okay.
I was on the right track. I just.
So I'm going to give you all tomorrow to work. I'm going to give you a hand-in as well tomorrow. So I would do some practicing tonight if you have time. If you don't have time, then practice your class, but try to do some every day. Starting next week, we're going to do the frictional coefficient lab, where you're actually going to find out what the new value is for wood on wood.
What is it?
Can't say. It's a secret.
Just give us a number.